Thank you for joining us. In this video, we're going to look at an introduction and some notes on using the law of sines. This sometimes also gets known as the sine rule. Okay, so let's look at our notes. So you've done solving right triangles, right? That you have, hey, here's a right triangle, and you have an angle, and you have your side opposite, and you have your side adjacent, and you have your hypotenuse, right? And using the sine ratio, the cosine ratio, and the tangent ratio. All right, but now we're going to work with what were called oblique triangles, which are non-right triangles. Okay. And in geometry, remember that you had angle, angle, side, angle, side, angle, side, side, angle, side, 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 angle, side. And what we're going to talk about is in certain situations here, depending on what you're provided, you'll be able to solve your triangle and find out the missing information. Okay, so this relationship, which can also be done with the reciprocals, is a very important relationship that gets known as the law of sines, and like we said, sometimes also called the sine rule. And what it says is that the ratio of an angle to the side opposite is going to be in a constant proportion between an angle and its side opposite, that ratio is going to be constant for any triangle. Okay, so let's talk about labeling triangles, right? That we have angles, you're going to use capital letters, and side links, you're going to use lowercase letters, right? So I could say, hey, here's angle A, and then opposite is side A, right? Or that here is angle B, and opposite is side B. Okay, so important notes is that you have to have a known value for any angle side pair to be able to use the law of sines. So if I have an angle and I have a side, as long as I have this pair with the angle and the side, then I can use the law of sines with one other piece of information, right? So if I could figure out another angle, or I could figure out another side, or rather I was given another angle, I was given another side, then I could figure out, use the law of sines. So in other words, if I had angle, angle, side, or if I had angle, side, angle, or if I had side, side, angle, all of these situations will give me the ability to use the law of sines. Okay, when you're using the law of sines, right? When you're using the law of sines, you could have 0, 1, or 2 solutions. With 2 solutions, that gets called the ambiguous case. Okay, and if you're solving a triangle, that means finding all 6 components. You got 3 sides and you have 3 angles. All right, when using law of sines, we're going to be working with the degree measure of angles. So it's going to be important that we work in degrees. In fact, if we look at our calculator over here, we look right at the top, it tells us that we're in radian mode. We're going to end up having to change that to degrees. Okay, so let's look at our situation. Okay, so our first example here, if we want to solve this triangle, this happens to be an angle, side triangle, right? That this happens to be an angle, side. Well, what do we know? I know from the law of sines, I know that the sine of 35 degrees, right? So this 35 degrees all over A is going to be equal to the sine of 103 degrees all over B, right? And B happens to be 20. Now, For a lot of students, it's a lot easier to say if I'm trying to find a side length, that it's easier to find the side length by flipping your ratio. So we could say that A over the sine of 35 degrees is equal to 20 over the sine of 103 degrees. Okay, and if we were to solve that, we'd be able to say that A is going to be equal to 20 times the sine of 35 degrees, all divided by the sine of 103 degrees. All right, so on our calculator, what's that going to look like? Well, first, like we said, we need to make sure that we are in radian mode. I can come to the home, go to my settings, and I want to change my angle measure to be degrees. All right, then I can go ahead and come back to my calculation, and I'm going to have 20 times the sine of 35, and I'm going to go ahead and close the parentheses, divided by the sine of 103, and that tells me that side length A is approximately 11.8 units. Okay, now angle C, right? Let's say that we called angle C theta over there. Well, what do I know about angle C? I know that 180 degrees minus 103 degrees minus 35 degrees is going to be that theta. And if I do that on my calculator, I have 180 degrees minus 103 and minus 35. And that gives me 42 degrees. Okay. So I know now I have a 42-degree angle. So what does that tell me for my 42-degree angle? I know that C over the sine of 42 degrees has to be equal to 20 over the sine of 103 degrees, which means that C is approximately 20 times the sine of 42, all divided by the sine of 103, and that gives me approximately 13.7. So notice that it tells me that I need to solve the triangle. And so A, B, C, angle A, 35 degrees, angle B, 103 degrees, angle C, 42 degrees, side length A, 11.8 units, side length B, 20 units, side length C, 13.7 units. So we have our angle and we have our side, and that is a solution for our triangle using that sine rule or that sine ratio. Okay. If we look at our next example, we want to solve this next triangle. And let's go ahead and move over. I guess I'll make this just a touch smaller so we can see. So we have our triangle that we're trying to solve, and we're told here that we're going to have no solutions. But let's just play with this a little bit. Let's say that I have a possible solution. Well, I'm saying I've got the sine of W all over 6, right? So this angle with this side, the sine of W all over 6 has to be equal to the sine of 78 degrees all over 5, right? Which would indicate that the sine of W has to be equal to 6 sine 78 degrees all over 5. Well, if I go 6 times the sine of 78 degrees and I divide it by 5, that's approximately 1.17. Therefore, I have no triangle possible. And the reason I have no triangle possible is that my sine ratio must be between 0 and 1. The sine ratio must be between 0 and 1. right? If my sine ratio is 0, then my angle is 0. If my sine ratio is 1, then my angle is 90 degrees, right? Otherwise, I'm going to be anywhere between 0 and 1. So this 1.17 can't work, right? Another way that you could reason through this is notice that this 78 degrees has the shortest side. But the 78-degree angle cannot be the smallest angle in this triangle. And because the 78-degree angle cannot be the smallest angle in this triangle, it cannot be opposite the side that is the shortest side. Why can I not have 78 degrees be the smallest? Well, if this was an isosceles triangle, I would have 78 with 51 and 51, if it was isosceles. Or I could start making one of these smaller and one of these larger. Regardless, one of these angles is always going to be smaller than 78 degrees, so 78 cannot have the shortest side across from it. For our next question, our next example, we're going to solve this triangle, and we have our given situation. So we look to see our ratios, and we know that we're looking for opposite pairs. We're looking for opposite pairs. And so let's say I call this angle alpha and I call that angle theta. Well, I know that if I'm trying to solve for these angles, I know that the sine of alpha all over 10 must be equal to the sine of 103 degrees all over 11.2. So therefore, the sine of angle alpha has to be 10 sine 103 degrees all over 11.2. So we'll do 10 sine 103 degrees, all divided by 11.2. That gives me 0.86997. Okay. Now, how can I undo a sine? I can use the inverse sine, and so I can say, hey, the angle is going to be given by the inverse sine of 0.86997. Okay, so what does that mean for me? If I do the inverse sine, that's going to be shift to the arc sine of that angle, and that gives me approximately 60.5. So alpha is about 60.5 degrees. And if alpha is about 60.5 degrees, right, so this is 60.5, then I know theta is going to be 180 minus 60.5 minus 103, which gives me 16.5 degrees. And so I've solved the triangle. I have my two unknown angles, and I have all the other values. And in this situation, once again, only one triangle was possible. Notice that the sine ratio we did get was a positive number between 0 and 1, which is what we need for our triangles. Our next case is going to be what we call our ambiguous case, and our ambiguous case has two possible solutions. Okay, how do we know I have an ambiguous case? Well, if I have an angle side side, if I have angle side side or side side angle, if you're going counterclockwise, I could be ambiguous. What does that mean for me? That means that I could have triangle 1, or I could have triangle 2, right? Triangle 1, A, B, and C, or I could have triangle 2, A, B, and C. A way to think about this and why it's true is to come over and say, let's say that I had a triangle that looked like this. That I had this angle, and that angle there, right? Let's adjust this just a little bit, right? So let's say that I had this, and I had that was angle alpha, and I had this was side 1, and this over here was side 2. Well, what if instead I took that side 2 and I rotated it in so it was the same length? Well, that would give me a second triangle that is possible, right? That if this over here was angle beta, then the angle right in here would be the angle 180 minus beta. And that's going to come into play for us. So for our first triangle, angle is angle of 43 degrees for either of our triangles, right? Side length C for both triangles is 25. Oh no, side length C is, 28. Side length A for both triangles is 25. Okay, so how can I solve these triangles? Well, I know one ratio, right? If I call this angle there theta, right? If I call this angle theta here, I know that the sine of theta divided by 28 must be equal to the sine of 43 degrees divided by 25. So 28 times the sine of 43 divided by 25, that gives us 0.763. Right, so theta is going to be the inverse sine of 0.7638. And if I go ahead and do the arc sine of that value, I get 49.8 degrees. So that's 49.8 degrees. So I have 49.8 degrees as my possibility. Okay, if I say 180 minus that 49.8 minus 43, that gives me 87.2. That is my other angle for angle B. That's my possibility. If I wanted to find that side length, I could say that the side length of B divided by the sine of 87.2 degrees is going to be equal to 25 divided by the sine of 43 degrees. So 25 times the sine of 87.2, all divided by the sine of 43, gives me 36.6 approximately. So that's my other side length. Right? And notice that the largest angle has the longest side. Right? But I have a second triangle possible because of the relationship. So I have to find the supplementary angle to the angle that I found. So the supplementary angle to 49.8. Right? So that supplementary angle to 49.8 is going to be 180 minus 49.8, which is 130.2. So now that's going to be 130.2 degrees. And then I'm going to use this same relationship, but with the 130.2 degrees, I can find my next angle, right? And my next angle would be let's have 180 minus 130.2 minus 43. And so that gives me a very small angle of 6.8 degrees. And if I look at my relationship, this relationship for side B would turn into B over the sine of 6.8 degrees must be equal to 25 all over the sine of 43 degrees. So 25 times the sine of 6.8 degrees, all divided by the sine of 43 degrees, and that gives us approximately 4.3. So those are my two triangles that are possible. Once again, it's important that you be in degree mode. And on the NumWorks, you can come to the home screen by clicking the orange button, scroll down to your settings, and make sure that your angle measure is in degrees. And that will allow you to make your computations. Okay, so that's it for this first video. We'll look at a couple of more examples in our second video for our notes. Thank you for your time.